Hello students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting topic, that is decimals. Now in this chapter we will learn about representation of decimal in the place value chart, representation of decimals on the number line, decimal as fraction, and what are decimal places. Now let's start with the introduction. In the introduction we have told that the word decimal means based on 10. The word has been derived from the Latin word decima, meaning a tenth part. The fractional numbers having denominator 10, 100, 1000, etc. are called decimal fractions or decimals. Some decimal fractions are expressed as given below: 4 by 10 as 0.4, 2 by 100 as 0.02, 3, 13 by 100 as 3.13. Always remember 2.5 is read as this and it can be read as 2.51. Here the dot is what? Our decimal point. So therefore decimal part consists of two parts, that is whole number part and another one is our decimal part. And they are separated by what? A decimal point. Now let's start with our representation of decimals in the place value chart. Now we know that in a place value chart, each place has a value 10 times the value of the next place on its right. For example, value of 100 place is 10 times the value of 10 place. Value of 1000 place is 10 times the value of 100 place. Now in other words, the place of a value is what? 1/10 of the value of the next part on its left. Now here consider the place value of 5 in the following. So what we have said that 1/10 of the 1000 place to the 100 place. Now the place value of 5 in this is 5000, in this is 50, in this one is 500 and in this one is 5. So what we have seen that the digit moves one place to the right, then the value becomes 1/10. And in the previous value what we have learned that when we move it two places to the right, it becomes 1 by 100 of its value. And if we wish to continue towards right, we have to extend the place value chart beyond ones by opening the places for tens, hundreds and thousand. Now let's look at the place value chart. Here is our ones, tens, hundred, thousand. Here is our tens, hundreds and thousands. Now if we represent this number in the place value chart, then we go 2 goes to the tens place, 3 to the ones and 5 to the tens and 8 to the 100th place as indicated here. Now the number shown here is our 23.58. It can be read like this, and dot is our what? Decimal point, and it separate our whole number and fractional part. Now similarly this number can be read as 739.214. Now it can also be read as, note that while reading a decimal number, its decimal part is read digit wise. That means it can be read as 6.2, it is 0.73, it is 37.64, and it is our 564.07. Now a decimal contains a whole number part and a decimal part. So in this one, the whole number part is 6, decimal part is 2, whole number part is 37 and decimal part is 64. Always remember the decimal consisting of only one part, either decimal part or whole number part, can be written by making us use of a 0 in whole number and decimal part. So it can be written as 23.0, it can be written as 0.29. Now let's start with the representation of decimals on the number line. Now you have learned to represent the fractions on the number line. Now representing a decimal and a fraction on the number line is one and the same thing. So in other words, we represent it on a number line. Here are the working rules. Step 1 says that firstly we draw a number line, then we mark all the whole numbers, then we divide the portion between the whole numbers into 2 or 3 or 4 equal parts as per our requirement. Let's start with our example number 1. Here we have to represent the following on the number line. So 0.5 is what? More than 0 and less than 1. And there are 5 tenths in 0.5. That means we will divide it into 10 equal parts. And here point A is our what? 0.5. Similarly in the second one, 1.8, that means it is greater than 1 but less than 2. So we will divide it into how many units? We will divide it into 8 parts as shown in the figure. So point B is our what? 18 by 10 or 1 by 8. Now let's start with the decimal as fractions. Decimals are another name of fractions whose denominator are 10, 100 and 1000. Now let us first define tenth. hundred and thousand as fractions. So what is a tenth? Look at the strip in the figure. It is divided into 10 equal parts and one part is shaded. The shaded part represents 1/10 of the whole strip. This is our what? 1/10 of the whole, and it can be read as decimal 1 or 0.1. Now the fraction 1/10 is called the 1/10. Here look at the strip, it is 7/10. That means 7 parts are shaded and the shaded part is 7/10 of the whole strip, or it can be read as 0.7. Similarly, all of these can be read as 2/10, 3/10, 5/10, 6/10, 8/10 and 9/10 respectively. Similarly, it is our what? 11/10, or it can be written as 10/10 plus 1/10, that is 1.1. 12/10 can be written as 1.2. 20/10 can be written as 2. 25/10 can be written as 2.5. Now from the above discussion, what we have observed that a fraction in the form of number by 10 can be written as a decimal obtained by putting decimal point to the right, that is 38.7, 760.5, etc. Now next is our hundreds. When we divide a square into 100 equal parts and shade one part out of it, then the shaded part represents 100 of the whole square and can be written as 1/100 or 0.01 or 1/100th. Similarly, if we divide 100 equal parts and 20 parts are shaded, that means it can be written as 20/100, or it can be read as 0.02 or decimal 20. Similarly, if we write it, it can be written as 0.18, 0.29, 0.75. We can also write 1.45, 1.64 and 58.08. From the above discussion, we have observed that a fraction is in the form of number by 100 can be written as a decimal point obtained by the decimal point to the left or of right two most digit of number. Now if number is short of digit, we insert zeros to the left of the number. Now here is our thousands. Similarly, 1 by thousands is written as 0.001. It can be read like this, and it is in the form of number by thousand. So the decimal obtained by putting 3 rightmost digits in the left side. Now if a number is short of digit, we insert 0 to the left of the number. Now let's start with the decimal places. The number of digits in the decimal place of a decimal gives the number of decimal places. For example, these are our 2 and 3 decimal places respectively. Here is our example. We have to arrange them in the place value chart. Here is the ones, decimal point, tenth, hundred and thousand, tens, hundred. 0.8, 0.8, 6.5, 28.73, and the last one is our 456.208. Now in example number 3, what we have to do, we have to write the decimal in words. So first one is 6.2, that is 62/10, that can be read as 6.2. Next is, it can be read as 38.76 or 38 and 76 hundredths. It can be read as 419.317 or 419 and 317 thousandths. Now let's start with exercise 9.1. In the first part, we have to find the correct option and fill it in the OMR sheet. In the first one, the decimal value of 12/10 is very good, that is 1.2. That's how you can complete the remaining parts. Now let's start with the expanded form of decimals. This is a form in which we add the place value of the digit forming the number. For example, we have to write each of them in the expanded form. So it can be written as 30 plus 8 plus 0.5 plus 0.04. It can be written as 80 plus 3 plus 0.1 plus 0.007. It can be expanded as 600 plus 20 plus 7 plus 0.07 plus 0.004. We have to write it in the decimal or short form. So it can be written as 9.34. It can be written as 57.624, and it can be written as 104.306. Now let's start with conversion of a decimal into fractions. So how we can convert? Let's look at the steps. Here are the working rules. When we write the given number without decimal point as a numerator of the fraction, we will write 1 in the denominator followed by as many zeros as the number of decimal places in the given number. Now what we will do, we will reduce the fraction into the lowest terms, and if required we will change it into mixed numeral. For example, here we have to convert it into fraction. It will become 675 by 100. In its lowest form it becomes 63 by 4. Again convert it into fraction. How many decimal points? 3 zeros. So this will become this, and in its lowest form it becomes 924 into 11 by 40. Now let's look at conversion of a fraction into a decimal. Let's look at these steps. Here are the working rules that we have to discuss. Step 1 says that firstly what we will do, we will change the common fraction into equivalent whose denominator is 10, 100 or 1000. Then we will count the number of zeros in the denominator after 1, and in the numerator what we will do, from the extreme right we will move the decimal to the left by as many number of zeros in the step 2. Now let's start with example number 8. Here we have to convert the following into decimals. Firstly we convert it into 75 by 100, and that can be written as 0.75. It can be written as 55 by 10 or 5.5. It can be written as 248 by 1000 or 0.248. Now let's start with converting a common fraction into a decimal fraction. For converting a common fraction into decimal, we follow the division method. Let's look at the working rules. Firstly, we divide the numerator with the denominator till a non-zero remainder is obtained. After that, we will put a decimal point in the dividend as well as in the quotient. After that, we will put a 0 on the decimal point in the dividend as well as on the right of the remainder whenever required. In the step 4, we will divide again just as we do in the whole numbers. In the step 5, we will repeat step 4 till remainder is 0. Now let's look at example number 9. We have to convert it into decimals. We will divide the numerator 3 by denominator 4. So 3 by 4 can be written as 0.75, and 1 by 4 can be written as 4.25. Now let's start with exercise 9.2. In the first part we have to write the following decimals in the expanded form. So 31.5 can be written as 30 plus 1 plus 5 by 10. That's how you can complete the remaining part. Now let's start with our like and unlike decimals. What are like decimals? 2 or more decimals having the same number of decimal points. For example, 0.7, 3.5, 6.1. These are our set of like decimals, each having one decimal place, and these are our like that have 2 decimal places. Now unlike decimals, that means which have different number of decimal places. For example, in these or all of these, they are unlike decimal because they have different number of decimal places. Now always remember, now the addition of zeros to the extreme right of a decimal part does not change the value of decimal number. That means 2.5 is 2.5. You can write as many number of zeros you want to write. Such decimals are called equivalent but unlike decimals. So without changing the value of decimal numbers, the number of decimal places can be increased by simply adding required number of zeros to the extreme right. Now converting decimal, unlike decimal into like decimal, we can convert by adding zeros to the right of it. Let's look at example number 10. Here we have to convert them into a set of like decimals. So what we have done, we have added 2 0, 1 0 and nothing here. Here we have added 2 zeros, 1 0 and nothing here. So all of these are like decimal with 3 decimal places. Now let's start with the comparison of decimals. We can compare them by following these steps. Here are the working rules. Step 1 says that we will compare the whole part of the given numbers. The number with greater whole part is greater 1, and if the whole parts are equal, we will go to the next step. Then we will compare the extreme left digit of the decimal parts of 2 numbers, and the number with greater extreme left digit will be greater, and if the extreme left of the decimal parts are equal, then we will compare the next digits and so on. For example, here which decimal is greater, we have to tell. Firstly, 78 is same, then out of 4 and 2, 4 is greater, so this number is greater 1. In example number 12, we have to tell which one is greater. So given decimals 35 are equal, but out of 4 and 2, 4 is greater. So that means left one is greater 1. In example number 13, we have to arrange them in the ascending order. On converting it, what we will do? First, we will find the smallest decimal, then the next smaller, and the other smallest in the ascending order. Now, after putting them, these are our ascending order of the required decimals. Now, example number 14, here we have to arrange them in the descending order. That means, firstly, we find the greatest one, that is 23.5. Then, next decimal, that is smaller than it, and the other decimals. So, this is our descending order of the respective series. Now, let's start with exercise 9.3. First is straight, true or false. In the first one, 0.31 and 17.02 are like decimals. Very good, it's a true statement. That's how you can complete the remaining one. Now, let's start with our uses of decimals in everyday life. Let us learn some uses of decimal notation in money transaction measuring length and weight. Money. We know that 100 paise is equals to 1 rupee and 5 paise is equals to 0.05 rupees, 75 paise is 0.75 rupees. Similarly, 10 rupees 45 paise is rupees 10.45 and this can be written as 75.5 rupees. Now, length. We know that 10 millimeter is equals to 1 centimeter and 1 millimeter is equals to 0.1 centimeter. So, 9 centimeter 5 millimeter can be written as 9.5 centimeter, and we also know that 100 centimeter is equals to 1 meter. So, 40 centimeter is 0.4 meter and it can be written as 42.35 meter and 68.75 meter. Now, we know that 1 meter is equals to 1 by 1000 kilometer. So, 75 meter is 0.075 kilometer. 528 meter is 0.528 kilometer. Similarly, it can be written as 29.054 kilometer and 12.075 kilometer. Now, we know that in the weight, 1000 gram is equals to 1 kilogram or 1 gram is equals to 1 by 1000 gram. So, 12 gram can be written as 0.012 and 85 gram can be written as 0.085 kilogram. 12.45 kilogram and it can be written as our 62.075 kilogram. Now, in terms of capacity, we know that 1000 milliliter is equals to 1 liter and 1 milliliter is equals to 0.001 liter. So, 75 milliliter can be written as 0.075. It can be written as 14.355 and it can be written as our 53.056 liters. Now, let's start with our addition and subtraction of decimals. Here we have to follow these steps. Here are our working rules. In the step 1, firstly we convert the decimal into like decimals. After that, we will write the number in the columns and then decimal should become in one column. Then we will add and subtract the decimal just as we add or subtract the ordinary whole numbers. Then we will place the decimal in the sum or difference directly under the decimal point of all the decimals. Let's understand it better with the help of our example. Here we will convert it into like decimals. After that, we will add them and this is our required sum. Here we have to subtract them. Firstly, we convert it into like decimals and this is our respective difference. In example number 17, we have told that Sameer spent this amount on maths book and this amount on science books. Then we have to find out the total money spent by Sameer. That means we have to add them. So, after adding it like the whole numbers, we will put a decimal in between them and this is the money he spent on his books. Now, next is our example number 18. Here we have told that Rashmi bought this kilogram of onions, this amount of potatoes and this amount of tomatoes. We have to find the weight of the vegetables he bought in all. That means we have to add all of them. After adding the sum, this is our required weight, that is 44.350 kilograms. In example number 19, we have told that Gautam spent 90.5 rupees and Rajesh spent 67.25 rupees on a picnic. So, how much more money was spent by Gautam? That means we will find the difference. After finding out the difference, Gautam spent 23.25 rupees more. Let's start with our exercise 9.4. Here we have to express each of the following using decimal points. So, first one can be written as 9.80 meter or 9.8 meter. That's how you can complete the remaining part. Now let's summarize the fractions with the denominator 10, 100 or 1000 are known as decimal fractions or simply decimals. A decimal consists of two parts, whole number part and the decimal part. The number of digits contained in the decimal part of a decimal gives the number of its decimal place. Decimals have same number of decimal places like decimals. Decimals having different number of decimal places are unlike decimals. Now let's start with our chapter and exercise. In the first one we have multiple choice question or take the correct option. First is 200th is written as, very good, that is 0.02. That's how you can complete the remaining part. Here's our mental maths. Every decimal number can be represented on number line. Here's the session and reasoning that you have to do it by yourself. Now I hope you have understood the chapter pretty well. You just have to practice the exercise question and don't forget to revise this topic again.